Good morning. Today we will discuss about length of a line segment. Okay. You know about a line segment, and we know how to find the length of a line segment by using a ruler, isn't it? So in plane geometry we use a ruler to find the length of a line segment. But when it comes to coordinate geometry, we have to use formulae for everything to find the length of a line segment or to find the midpoint of a line segment, etc. We need to use a formula. So let us see what is a formula to find the length of a line segment. Consider a line segment AB, which is on the board. You can see a line segment AB with the end points are A and B, where A has the coordinates x1, y1 and B has the coordinates x2, y2. Remember we discussed about coordinates in the last class. Okay, so A x1, y1 and B x2, y2 are the end points of a line segment. Okay, then the equation to find the length of a line segment is the equation to find the length of a line segment is under the root x2 minus x1 the whole square plus y2 minus y1 the whole square. So the equation to find the length of a line segment is under the root x2 minus x1 the whole square. That means change of x the whole square. Find the difference of x the whole square plus difference of y the whole square. Square root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared is the equation to find the length of a line segment. Now let us see how to find the answer using this equation. Let us consider a line segment of n points a23 and b57. So we have a line segment of n a23 and b57. We have to find the length of this line segment. So to find the length of this line segment, you know the formula as length of AB. We have to find out length of AB. For that, use the formula square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Remember the formula, and every problem we have to use the formula. So let's find out what are x1, y1, x2, y2. It's very simple. We have the first point. Let's consider this one as x1. This is x1 and this is y1. This is x2 and this point is y2. So anything can be considered as x1. You can consider this one as x1 or this one as x1. But as for our convenience, the first point is x1, y1, x2, y2. Now substitute in the equation. We get square root of x2 minus x1. That is x2 is 5 minus x1 which is 2. So x2 minus x1 is 5 minus 2. The whole square plus y2 minus y1, that is y2 minus y1 means 7 minus 3, the whole square. So when you do this one, we get square root of 5 minus 2 is 3 squared plus 7 minus 3 is 4 squared, which is equal to what we get, square root of 3 squared is 9 plus 4 squared is 16. That is square root of 9 plus 16 is 25. So square root of 25. What is square root of 25? Yes, it is 5 units. So the length of the line segment AB is 5 units by using the formula. Next question is P minus 2, 3 and Q 7, 10. Find the length of PQ. We have to find the length of PQ. So let's write x1, y1 and x2, y2. So here x1, this is x1 minus 2 and this is y1. So that x2 is 7 and y2 is 10. Now our formula is equation of the length of the line PQ is square root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared. That is equal to square root of, replace the values, proper replacement of values. X2 is 7 minus x1. What is x1 here? Minus 2. So x1 is minus 2 the whole squared plus y2. y2 is 10 minus y1. y1 is 3 the whole square. So we get it as square root of 7 minus into minus is plus 2 the whole square plus 10 minus 3 is 7 squared. That is equal to square root of 7 plus 2 is 9. 9 squared plus 7 squared. That is square root of 9 squared is 81 plus 7 squared is 49, which is square root of 81 plus 49. How much is 81 plus 49? Yes, it is 130 as answer. 130 units will be the length of the line segment PQ. Let's do another question. Find the length of the line segment XY in which X is minus 3 minus 7 and Y is minus 9 minus 2. Okay, in this question also let's write x1, y1. It's similar method. Okay, x1 is minus 3, y1 is minus 7, x2 is minus 9, y2 is minus 2, x1, y1, x2, y2. Okay, so the length of the line segment xy is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, which is equal to under the root x2 minus x1. Let's replace it. x2 is minus 9 minus x1. x1 is minus 3 the whole squared plus y2 is minus 2 minus y1 minus 7 the whole square, which is equal to under the root minus 9 minus into minus is plus 3 the whole square plus minus 2 minus into minus plus 7 the whole square, which is equal to, now let's find the answer for this, that is square root of minus 9 plus 3 is minus 6 the whole squared plus minus 2 plus 7 is 5 squared, which is equal to under the root minus 6 squared is 36 plus 5 squared is 25. We get it as square root of 36 plus 25 is 61 units as answer. Okay, the next class we'll discuss about the midpoint of a line segment and followed by the internal division of a line segment by using sector formula. Thank you.